Hello, my name is Gavin Blazer. I'm in 10th grade, and the focus of my STEM fair project was lowering the freezing point of water. This is the background and setup to my project. On the far left, we have the ice bath that I created that I would put all my test tubes in to lower the freezing point of the water. In the middle is the 2.9 grams that I measured out for my first sample of sodium chloride. And to the far right is myself mixing with the stirring rod the 2.9 grams with 100 milliliters of water. I used 100 milliliters of water to keep it the same on every single one, and then after I had it completely dissolved and stirred in, I would put it 1/3 of the way in a test tube of that water and sodium chloride or sucrose solution, and then I would put the test tube in the ice bath, and the ice bath would then lower the freezing point of it, and when it started to form crystals, I would record the temperatures. This was my salt results from using salt to lower the freezing point of water. We have on the far left 2.9 grams of sodium chloride, and that ended up freezing at -1 degrees Celsius is when the crystal started forming. Test tube number 2, 5.8 grams, started at -2.5 degrees Celsius forming the crystals. And then the last test tube 3, 11.7 grams of sodium chloride, we had starting to form crystals at -5 degrees Celsius. All of them look pretty good with the crystals, and I was very happy with how that turned out. Here we have sugar to lower the freezing point of water. On the far left is the 17.1 grams of sucrose, which ended up freezing at 0 degrees Celsius with the crystals there. Test tube number 2, 34.2 grams, started freezing at -3 degrees Celsius. And then test tube number 6 there, 68.5 degrees Celsius, 68.5 grams, of sucrose with freezing point -5 degrees Celsius. A nice correlation between putting more sucrose and lowering the freezing point, which is what I hope for. In case anyone wanted anything repeated, we have the data table here from my results. And there was a very nice correlation, as I mentioned before, between adding more grams of sodium chloride or sucrose and lowering the freezing point, which I was very happy to see. Testing the accuracy. The last thing that I did on my experiment was I tested the accuracy to see what the expected degrees in Celsius should be at the freezing point versus what I actually got. And the results came out pretty well. The first thing I did was I calculated the molality of each different measurement grams of sucrose and of sodium chloride. The amount that I used in grams worked out so that it would equal the same type of molality for each different measurement. 0.5 for number 1 and 4, 0.99 for numbers 2 and 5, and 2.0 for numbers 3 and 6. The expected freezing point calculations that I did in the equation was the Van Hoff factor, and I multiplied that by the molality and times the molality freezing point, which was my constant, which was Celsius over molality. In the molality of the 0.5, 0.99, and 2.0 I used was moles per kilograms. And when I did that, in the end, I got -1.86, 3.68, and 7.44, and then -0.93, -1.84, -3.72 degrees Celsius. All negative, all in Celsius. And if we go back to my data table, I got -1 degree Celsius for the 2.9, which was awfully close to the -1.86, -2.5 degrees, which was close to the -3.6, and -5, which is awfully close to the -7.44. If we go over to the sucrose, I got -0.93, which was close to the 0 that I got with the 17.1, -3 for the 34.2, and that the expected should be -1.84, so not far off, and then -5 for the last one, and I got -3.72. So all were relatively close. It is expected that they should be off. I tried to keep the ice bath in between 8 degrees Celsius, -8 degrees Celsius, and -10 degrees Celsius, but that's a little difficult with the homemade ice bath. like that, but I am happy with the results, and I figured out how to lower the freezing point of water. Thank you very much for listening.